Hey, Michael.
Hello.
Thanks for coming in and meeting with me about your post-observation conference.
Sure. Thanks for having me.
So I really enjoyed coming into your class. I know that before spring break, you had added the drawing to learn process, to your hands-on science activities, and thank you for doing that. I appreciate you participating in that initiative. Well, during your lesson, I saw that every student was building the circuits. I saw that they were talking with their table team, they were drawing, they were labeling diagrams, working in their notebooks. I especially noticed that your classroom routines are really, really strong. And I saw that your materials moved quickly, the transitions were smooth, there was no downtime. Students were focused. So, what are some of the other strengths that you think you had during that lesson?
I like that I provided the scaffolding for them, just because I've seen that sort of in the past. They kind of struggle with the actual drawing, especially many kids, they just don't have a good grasp of like white space. They try to clump it all together. And then we did that with the water cycle, and I just had them draw it on their own. I couldn't read some of their drawings because they drew them so small, and then they basically had these labels and I didn't even know what it was pointing to. So this way, it was going to have the materials. I knew that I needed them to label and just kind of put them spaced out a little bit and then let them sort of connect the dots, if you will, to kind of build it.
Yeah, I noticed that made it really easy and to see what was going on, and thank you for designing that. That's awesome. Anything else?
Well, I tried to do it in a way that also wasn't giving away too much information. Like the battery, I just kind of drew the cylinder. They actually had to label it as like positive, negative. I wanted them to add the bump on the positive side. Kind of the same thing with the light bulb. Like I wanted them to actually, practice if it was on, I wanted them to kind of draw the little, lines to sort of show that it was illuminated. Just so we can kind of work on that a little more.
Perfect. Yeah, that's great. I want to add a few more things to those things. You had sentence frames, the label diagrams that you had for the after when they could see what it was really supposed to look like that they put in their notebooks. They had the reference diagram also from other lessons and the MELTS anchor chart. So you just had all of these different multiple ways for students to access the content, and I thought that was rich. And also they were making their thinking visible thanks to your forethought and your planning to help them organize their drawings. And then I saw you correcting students' thinking as you circulated around the room and you were checking their diagrams, and that certainly, the drawings make it easier to check to check their thinking. So anyway, overall, really great. One thing that I did notice that is an opportunity for improvement, when the students showed confusion, especially around the open versus closed circuits, the lesson quickly moved into review. And the students were engaged, and they referred to their reference page from the other lesson to see what was going on with that. But I just thought there was a missed opportunity to probe them, to explain why. So I'm wondering, so this is the highest leverage action step I think that we could take for a science lesson like this. So what could you do to help students go beyond just open or closed and probe them as to why that causes the light bulb to glow?
I think something that would probably be really good is if I start using more students to do the explaining as opposed to me doing the explaining, just because kids learn best from kids. To maybe have some of them come up under the doc cam and sort of show their drawing and also interpret it in their way and in their words to kind of point it out to other students. I think that could be beneficial. Maybe having them do a little more of a turn and talk before they actually dive into it. That way they're able to kind of orally tell the story before they have to individually draw it. And then I also think for my SPED students, I need to kind of increase the accommodations a little bit and possibly give them a word bank too. Because I did notice that was one of the misconceptions that happened with not really a whole group, but some individuals in the group, and I think part of that was they're just poor spellers and they really needed kind of the extra scaffolding.
Right. Perfect. I noticed that in your room you have so many, like your gen ed classroom, so you have to have anchor charts for all subjects, and there's not a lot of space for science on your walls. I mean, you're already kind of flooded with that. So yeah, a word bank would be great. Maybe even vocabulary list in their notebooks. Yeah, cool, great. What about process arrows, and how could that help with this?
As in, like, showing how the process actually kind of flows. That'd be another thing I'd love to have, because I had some students that did a fabulous job really not only showing the arrows but also documenting it with short little paragraphs.
Yeah, I noticed
I'd kind of like to feature them, to have them come up and sort of again
kind of the
teach
exemplar
it.
lesson.
Actually be the student exemplar, because I mean some of them I thought did better than my own exemplar.
Yeah, they really did a good job with that. Awesome. Okay, so I think I was going to ask you, like, how can you use drawing and labeling to clear up misconceptions in future science classes? But I honestly think with some of these examples, you hit on some of that. You will have your next lesson coming up is going to be on moon phases, correct, or lunar cycle. So I guess in preparation for that and in anticipation of other misconceptions or confusion, what is a common misconception that students might have about the lunar phases?
In fourth grade, I think there's a lot. I mean, some kids don't even fully understand like the orbit of the solar system. So sometimes they're not really sure why the shadows are happening, if the moon is moving, or if the earth is moving, or if they're both moving, or how they move in sync or out of sync, or where that shadow is actually being cast from. So I think there's a lot to go over in fourth grade.
Okay.
And I think it's another one that when we're doing the labeling, just to really make sure it's simple, I want to provide some type of scaffolding that is showing kind of the same way on the test of how the lunar cycle is often portrayed.
Right, because it's not the shadows that we're seeing, it is the amount of light that is visible to us, right, as it's
depending
going.
on, as the earth is like moving around.
So, I think probably having hands-on. There is a really great, a couple of great like video demonstrations of that, showing, if you've got the light coming in and showing the moon revolving around the earth, like the moon revolving around the earth, and just like the amount of light that is visible depending on where it is in its position. There's some really good things. I think another hands-on, which is going to be kind of tricky because it's not like it's just a circuit where you can
build it and manipulate it.
Right. There's a little more, and you got to like turn the lights out, have the right lamp facing, and otherwise using a video is pretty good too. And there's some the drawing. I think like what other types of things might you might you use for that?
Have you done it with the styrofoam balls before? That was one thing that I was kind of thinking of, either to build an anchor chart physically showing the styrofoam balls with the various, lunar cycle. And again,
Moon
I think
phases,
the moon phases. I think the challenge is also, again, like you said, that you have to shine the light just right and the angle and the darkness.
Yeah.
So it's kind of hard to model it.
It's hard for the kids
the
to do it.
classroom.
I mean, it's hard for the kids to do it at tables like they were with their circuits. Like, it's gonna have to be like in a small group or something. Yeah, I think that's good, and definitely they've got to see it. Especially if they are turning around with a light behind them, up over here behind them, and the earth is your head, and is that the one you're talking about?
Mm-hmm.
Yeah, we were doing it with the just a globe, a styrofoam ball, and the lamp in 5th grade, and that one was a little tough to do.
I'd almost like to do it with a little bit of kind of like a reader's theater, bring in some ELA, where maybe instead of using an actual light that they're simply representing as the earth, and we have like the physical model made of the lunar phase, and so that way, like, we're not actually casting a shadow.
Right, but you can hold it up.
They could hold it up, exactly, and kind of use it almost as multiple members of the class to kind of see, as you're the earth.
And they really only need to know the order. They need to know the order. They need to know that it's a cycle. They need to know it takes 29 and a half days. And that's a really neat idea.
But you always have those kids that want to like act it out, so they could just take turns being either part of the phase or part of the earth or even the sun behind the earth. And as you're spinning around, you're calling out like the different phases that you're pointing to as you're seeing it.
That's neat. I mean, that's actually a really cool idea, a way to get everybody involved when you can only do, when it's not like they're all going to have their own model. Like, you're getting everyone involved to see, and then they could probably be filling out their diagram while that's going on. So that's a great idea. That's a great idea for hands-on modeling, because this is a tough thing to show in 4th grade. Okay, so probing questions, if you were going to ask, what are some that you could ask about?
I think the big one is like, where's the light coming from? Because there's so many kids that have that misconception that the moon just naturally glows, not understanding it's reflection from the sun. What side of the moon is lit? I like having that conversation about the two sides of the moon. How much can we actually see from the earth, I think would be good, and maybe to also kind of think about it, I guess, is it going to be too hard, do you think, in 4th grade for them to conceptualize, okay, well now what if we were in South America, like how would it change if we were in a different hemisphere? Is that jumping too hard, or?
It won't change, but we will not go there, because that is probably above and beyond, right? Right? Yeah, that's always so interesting. I always find that we only focus on constellations in the northern hemisphere, and there's a whole other view.
Yeah.
But but there might be kids who, as you know, who will ask you a question about that. And so be prepared.
I have a girl whose family's from Australia, so I occasionally get those types of questions. That's why I was, is that too far? Which I guess, for 4th grade, to get them to understand it might be too much.
Yeah, and that is kind of a, I don't know, in science especially, some kids are just interested and already have a little bank of knowledge about it.
But then also to go over eclipses as well.
Yeah, that is definitely an older. We actually talked about that too. We talked about, like, it's only possible, like, just the sun, moon, earth. Okay, well, what would you have here? You could only have a solar eclipse, and that rarely happens. If it's over here, you could have, only on the rare occasion, a lunar eclipse, but we said that is rare. The cycle the moon is always visible. Like in the cycle, it's always visible. But that whole thing about being clear about new moon, because some kids will say it's because there was an eclipse and not because we are seeing, if this is the earth, here's the sun, here's the moon, this half of the moon is lit up, this half is dark. So I think really having those, we're gonna have to have lots of models to give them those options, because it seems relatively simple, but to me this is one of the more difficult things to teach. So let's just practice this action step, which is asking probing questions. So you're teaching the lunar phases, and during the course of a lesson, a student says, we see moon phases because Earth's shadow is covering the moon. So what are you gonna do?
Let's see. Well, I think that's one of those times that instead of just verbally correcting, it would probably be better to do what you literally just did, is just start modeling it out.
Yeah.
That, right. Or actually watch a video.
Okay.
Because I think if they're already getting that misconception, that just verbally hearing it is not going to be enough for them to really understand. I think they have to physically see, where the light is, why the shadow is where it is. So I think in some type of model, I think would be best for that.
Yeah, I think that is probably non-negotiable at some point. But before that, would you figure out who might know and who might not know? Would you question the students a little more?
Yeah, I would probably do a turn and talk and possibly see who would be willing to explain, and who wants to kind of be the brave one to sort of go over it for the class. Give some students a chance first.
Okay. Yeah, that's kind of what we're gonna just make them think about it first, and then maybe they'll turn around. But even if they have expressed doubt or a misconception, yeah, gotta get to the modeling and the video eventually. And I know you'll have those queued up and ready to go. And yeah, and I think the other thing I was going to ask you is, if somebody asks about a lunar eclipse, again, what would we do about that, since that's not really a fourth grade teak?
I also think maybe they could look back at their diagrams and kind of see, put yourself in the perspective, and what would you see if you're looking back at the model that we have all labeled, and see if they can actually, decipher it on their own.
Okay, good.
Or possibly even, again, maybe have the various objects that they could use to represent the sun, the earth, and the moon. And if you played with this real fast, how do you think an eclipse would happen, and why?
I think that is, that's perfect. Okay, and then with those diagrams, what are you going to have them do? Are you going to have them label and then explain, write an explanation?
Probably very similar to what we did with the circuits, where they're going to have, again, sort of the action arrows showing the order the cycle goes in, and then a couple sentences for each one to kind of explain, what is happening.
Okay, perfect. All right. So I guess to recap, if you are, for your next and future science lessons, so you might want to note a few things. If the students have some misconceptions or they're confused, you can first pause and ask probing questions.
Okay.
And try to get the students to work towards explaining the answer, just like we've discussed. And the students they can refer to diagrams or their drawings. I just think it's great that you have, at the end of those lessons, you're providing them with one that's filled out, like a key almost, a reference page. That's great, so they can refer to those because they're correct. They are, and then they can draw and label their own model. and that you had some great ideas also about having them share their work with each other, turn and talk, or having some of that exemplar work, maybe with some of those stellar explanations up on your doc camera, and just guide them to clear up the misconception, and then they're kind of like, yeah, teaching each other, and but they, they're not going to do that without your guidance.
Okay.
So I think you've got really strong systems, very engaged students, and if we consistently connect the hands-on work with the drawing and explanation, especially when the kids are a little bit confused, you're going to see that how their thinking is going to evolve, and the misconceptions like the open versus the closed circuits and even lunar phases are going to go down.
Mm-hmm.
So thank you for letting me come and observe.
Oh, absolutely.
And thank you for taking the time to help me with this.
Yeah,
really.
No, this has been a great, kind of professional growth for myself. I mean, I've already noticed with both the water cycle and then the circuits, like it really is kind of clearing up some of their misconceptions and getting them a little bit more concrete versus what I was doing before was just kind of notes, and it was just a little flat. So no, thank you.
I'm so thrilled. Well, all right, thanks again.
Mm-hmm.